Hey, welcome back to the Routing Loop, everybody. I'm joined here with Tom. Say hi, Tom.
Hi, Tom.
And we were just back from reInvent. I first want to point out one thing. Tom had asked me, he said, "Hey, Jamie, can you host for me for this last session? It's a Christmas session. Let's wear our ugly Christmas sweaters." And Tom did this on purpose so that I would only be wearing the sweater and he can make fun of my sweater. I'm absolutely sure.
I really did want to wear my sweater, but I just moved and I think I lost my ugly sweater in the move. I have a
Yeah.
suspicion that my wife had something to do with it because I
Yeah.
really like it was super ugly. It was like had lights on it and a reindeer. I think she might have gotten rid of it for me. So
Well,
yeah,
next year, I guess.
next year I need to
And we'll
find
do.
one. If folks have recommendations, pop them in the chat. I'm curious to see some good ideas for ugly Christmas sweaters.
Yeah, exactly. Also, how was reInvent, Tom? You had fun there? What'd you
Yeah,
do?
it was fun. I feel like I spent most of my time in the shuttle because I was kind of shuttling back and forth from all different locations. But I did manage to bump into a lot of people, some folks that are watching us every week. Put some handles to the names. I think you got a chance to meet TechField as
I
well. I
did.
I,
I
I
did.
I think I missed that, so I still don't know how TechField looks like.
Tech Field looks very good. Ask some knowledgeable questions at the door. It's one of my breakouts that I did for which one was that? I think that was the deep dive on ELB I did with Matt and with Milind Kulkarni, who's a PM of NLB, and he was out there, and he's like, "Yeah, it was pretty cool." So what sessions did you do at reInvent?
So I had a couple of Ask Me Anything with Matt Lewis, where we would just like take questions from the audience and spend the whole hour just whiteboarding. And then I did a session on network firewall that I think just got published. Network firewall proxy. Sorry. So the same topic that we're talking about today, I did a session in reInvent. I won't be reusing the slides. We'll just whiteboard today, but you can watch the session on demand. I'm going to try and pull that out and share it in a second as well.
Nice. And rumor has it you have a demo prepared as well.
Yep, I do have a demo. Hold on. And I have the session that I can share here in the chat as well.
Perfect. Yeah, I should probably also share my sessions too, just because, I can't have you just share your session and not share mine. But I'll do mine at the end because yours is actually more relevant to the topic of today.
Yep. And I see Erie Edits is joining. Erie Edits, were you at reInvent?
Yeah, I don't know. And let's see, let's just say the hi to everybody. No, not this year, I guess.
Oh,
Oh, I keep saying this every year. We should, and folks, let us know if we should do this, but we should do something for the routing loop, either like a routing loop session, right? Where we can maybe stream and just record it and then put it on the routing loop page, even if it's not done live because it's taken up, or maybe even stream to. I still have the
yeah.
routing loop YouTube channel. We can stream it to that maybe or something. But
Yeah.
we got to do something and get some of our folks back, and maybe when they ask questions, we can actually show them live or something. I don't know.
Yeah.
Maybe that will be our think big for reInvent next year.
It's a fun idea, actually. Yeah, we could do a live stream of the routing loop. Yeah, and I think you're right that we might not be able to stream on Twitch because that's going to be taken over by other reInvent stuff. But maybe having a live session so folks that are watching us could come and say hello, and we could hang out and just live stream from a room.
Yeah. I
That'd be
think
cool.
that'd be very, very fun. All right, you going to kick us off on what you want to learn us this year?
Yeah. Well, so we're going to talk about Network Firewall Proxy, which is a very fresh launch from last week or 2 weeks ago now.
Yeah.
Um, we we had a lot of customers using Network Firewall, the traditional firewall, and kind of asking us, okay, you either use the traditional firewall that's doing traditional firewalling, or as a customer, you would typically build your own self-managed proxy fleet. Right, where you would, get some open source proxy or third-party explicit proxy solution, and then manage it yourself, scale it yourself. So there was a lot of asks we were getting about, hey, could we have an option for a managed explicit proxy, which is slightly different to the traditional network firewall or next generation firewalls. So that's where the launch came from. We can do a quick comparison probably in the beginning, because just to set the stage of like explicit proxy versus transparent proxy,
Sure.
because that could be interesting for folks, and then we can just whiteboard how it works, and we can probably go through a demo and the whiteboard on the side.
Yeah, there's TechFueled. Yes, TechFueled.
Oh.
It was great seeing you there too. So were you avoiding Tom? I just want to know because he can be kind of scary. You didn't have any questions for him and ask me anything. So used to coming to
Yeah,
this show.
TechFuel just wanted to avoid me.
Yeah. No. TechFueled is a very cool dude. So on the transparent firewall versus explicit firewall, what would you say are the main differences?
Transparent and explicit, those are the biggest differences that you will see. Like, how do you get traffic to that thing, right? Transparent, as you can imagine, you don't have to configure anything on the client. You just make sure that your network funnels traffic through a firewall somewhere. The clients might not even be aware that they're passing through a firewalling solution. That's all up to the network administrator. With an explicit proxy, the model is slightly different. There is no routing. You can have a completely isolated environment, no routes anywhere, and then send traffic to an explicit proxy by updating the client and telling the client, hey, if you want to talk to the outside world, you got to talk through a proxy, and here is the proxy endpoint that you need to use to do that. And the communication then slightly different to what you would see in a transparent traffic flow.
Kind of reminds me of the old days when we did SOCKS. Remember SOCKS proxy?
Yeah,
and you would have to edit your Linux configurations for your resolution, resolve.conf, and also your routing to make sure it goes to the firewall first before it goes outside.
Yep.
Yeah.
All right, maybe look and get the, let me share my screen.
I think I dated myself by saying SOCKS, didn't I?
No, SOCKS is still happily
The
alive.
main thing?
Yeah, it's a thing. It's not dead. The network firewall proxy solution is not supporting SOCKS today. It's only supporting HTTP, HTTPS, but SOCKS is super valid.
Okay.
Okay, so let's start about talking first about the models. So we have the transparent, sometimes transparent firewall or transparent proxy. And then we have an explicit proxy. So an example of a transparent firewall proxy would be network firewall. And now, because the naming convention, right, we have this top-level service now, network firewall, that ultimately under the hood has two different things. One is kind of this traditional firewalling model. So we're just going to call it network firewall for a second here. So that's the next generation firewall that's been out for years now that folks might be already familiar with. And then we have the proxy model, which is the network firewall proxy. They're under the same kind of top-level umbrella of network firewall, but the APIs are different, configuration is different, policies are different, at least for now. So there is kind of a slightly different way of how would be configuring and how you'd be thinking about configuring your explicit proxy.
And are they both Suricata for their rule sets?
Nope. Different rule sets. So Suricata is used on the network firewall. Network firewall proxy has a completely different set of rules and actually different set of places at which you can apply your rules. So different set of phases. All right, so we'll dive into that, how that looks like exactly. But let me quickly explain the transparent versus explicit. So transparent, imagine you have a VPC. And inside that VPC, you have an EC2 instance. And maybe you want to pass it through the firewall before you let it go out to the internet. Right, so actually, maybe let's make that VPC a little bit bigger because that's going to be hard to show. We're just going to do a single VPC for now. So single VPC, I have an instance. I will have a NAT gateway, right? I need to NAT traffic before I go out to the internet, and I have an internet gateway. It gives me access to and from the internet. If I just send the traffic to the NAT gateway, just route it. So ultimately here, I would just say my default route is NAT gateway. Traffic hits the NAT gateway. We change the IP address to that of the NAT gateway and then send it out for the internet gateway out to the internet. If in this model you wanted to add a next generation firewall, whether it's AWS network firewall or it's a third-party appliance that you love that you can put behind the gateway load balancer, you would insert that somewhere in the path, right? So you would add that component in the path. So let's say this is network firewall. And then there's going to be a network interface or an endpoint representing the network firewall. And from the routing perspective, you're now saying, where I'm going out to the internet, go to the network firewall first. And this is configuration on the subnet route table. So you don't have to touch the instance itself, but the subnet route table in which this instance lives. And this routing will apply to everybody in that subnet. So now everyone in the subnet of that instance has to go to network firewall. On the network firewall, that would usually be in a separate subnet, right? So we would have a subnet boundary here, a subnet boundary here. NAT gateway would be in its own subnet, and each subnet has a different routing behavior. Once you're on the network firewall, your next hop is the NAT gateway. And once you're on the NAT gateway, your next hop is the internet gateway. So that's how you're getting traffic out to the internet. And then the network firewall inspects the traffic, looks at source and destination IP addresses, what have you, and decides, if it wants to allow, deny, looks at the policy. You can do TLS decryption if you want to and look deeper into the payload. So that's where it's kind of operating as a transparent firewall. If you do TLS decryption, it operates as a transparent proxy. So it actually receives your connection, terminates TLS, and then creates a separate TLS connection to the destination, allowing you to look inside of the payload and do some additional controls on the payload.
And that will pull the cert so that it can actually decrypt from ACM, right?
Yeah. So there is some differences between how the TLS decryption is done. So network firewall is using ACM, so you can bring your own certificate into ACM. With the proxy side, we're using private CA. So there's a separate service on the certificate management umbrella specifically focused on creating private certificate authorities, private certificates. So Proxy integrates directly with private CA.
Which makes a lot of sense too, because a lot of the times the network firewall proxy is generally used for internal workloads.
That's right, yes. It would be internal workloads trying to get out to the internet, yeah. Okay, so let's say we have a similar scenario here. We have an instance and we have a NAT gateway, and then we have an internet gateway, right? And these guys are in different subnets. So that's one subnet, that's another subnet. Let's call it subnet 1, subnet 2. Kind of like here, we had subnet 1, subnet 2, and subnet 3. In this subnet, I will not have a default route. So there is no default going anywhere. Doesn't exist. What I need to do is I need to add this proxy service or proxy feature into this VPC. Where the proxy lives is actually on top of NAT gateway. So I would create a proxy configuration, and that would be attached directly or associated directly with the NAT gateway, which is kind of nice, right? You already have a NAT gateway, so it allows you to just say, okay, you know what? I want that NAT gateway to also operate as a proxy. I'm going to attach a proxy configuration and make this NAT gateway a proxy.
Does that work only for the NAT gateway for the VPC, or does it work with the new global NAT gateway as well?
Only for the VPC, yeah. I think we did launch a regional NAT gateway where it doesn't live inside a VPC. It kind of gets abstracted away as kind of part of the kind of global regional, becomes like a regional endpoint that you can NAT through. Currently, proxy is not supported in that model. It's only on the XAML NAT gateway. So proxy configuration, and there's a second element that gets auto-generated, and that is an endpoint. So this is like a pretty standard VPC endpoint that will have
private
an IP address.
grabs an IP from the local subnet, unidirectional stateful flows, all that fun stuff.
Yep. So it's ultimately an endpoint that as soon as you create a proxy, we'll create an endpoint for that proxy in the same subnet where the NAT gateway is. So what's going to happen next is for the clients to be able to use the proxy to get out is you need to update configuration on the instance and say, hey, buddy, you're using a proxy to get out, and here is your proxy endpoint, and it will point to the endpoint here. So whenever the instance is trying to connect, it will initially send the connection to the proxy endpoint. The proxy will receive it, apply its policy, and then if traffic is allowed, it will NAT on the NAT gateway and then pump the traffic out to whatever the destination was.
And one little thing to mention too is the endpoint that the proxy places on the NAT gateway subnet also has a security group. So please make sure that security group actually allows the servers that are supposed to communicate with it to actually talk to it. That
Good
was my
call. Yeah.
mistake in beta. I was like, "What's going on?" And I applied a security group that I didn't realize it didn't include what I was actually trying to test with. So
Yeah. I feel
I
like
make mistakes.
90% of the issues I run into or I run into with customers is there's really two things that go wrong. One is security groups. The second one is routing. There's
Yeah, I was
either
gonna say that if you didn't mention it, that was mine too. It's like they do all the default routes on the VPC, and there's no like subnet routing, and they're expecting like VPC is a link local thing. So if two things can see each other and you don't have explicit routing, they're going to talk anyways. So it's not going to go through your explicit routings on the general overall VPC default. So Tom is recommending, we always recommend put your routes on the individual subnets.
Yep. I see a question from Tech First. By the way, Tech First, are you in any way related with Tech Fueled?
Yeah, there's a hyphen there, so in an F.
Yeah, there's a lot of tech, but good questions. Keep them coming. And Tech First, were you at reInvent? Because I know a lot of people met Tech Fueled. Tech Fueled, I was there. I'm sorry I didn't see you. I would have loved to meet up face to face.
Tom was hiding in Mandalay Bay, Tech. So,
Yeah,
all right,
in
so
a
back to
shuttle.
Tom. Yeah, in a
Um,
shuttle.
yeah. So we have a good question here. Even after enabling the proxy on NAT gateway, can the NAT gateway still work as normal? And the answer is yes. So if you maybe have another subnet, let's just add another subnet here, right? And then this subnet one, I don't want to have a default route. The only way to get out is through the proxy. Maybe now subnet 3, I don't need to use a proxy. I just want to get out. I want it to be just a pretty standard private subnet. So I want to route through the NAT gateway. So I can do this. I can put a route here. I can send it through the NAT gateway. And traffic will just route to the NAT gateway. NAT gateway will not this traffic and allow me to get out. The very big call out here is proxy is not triggered if you're just routing through the NAT gateway. So you can use the NAT gateway in this dual state as a NATing solution without a proxy, or as a proxy, but not both at the same time. So you can't route through the endpoint. You can only proxy through the endpoint. But you also can't proxy if you just route to the NAT gateway. So it's one or the other, but you can do both at the same time, but you're not getting the proxy functionality if you're just routing through the NAT gateway.
Yeah, so basically proxying through that endpoint tells the traffic to go through that extra layer of proxy firewalling goodness.
Yep. Yep. Okay. Wonder if we should jump into the demo and then draw things out, because there's I think one other thing I want to call out is there's an interesting flow of how proxying actually looks like. Right. So if we say, here is our proxy client. All right. So this is our instance that needs to get out to the internet. And then we have our proxy on the NAT gateway. So with accessible for the endpoint, I'm just not drawing the endpoint here. And then we have some internet destination, right? So internet. Let's say this is Amazon.com.
I'm sure a lot of people are going there this holiday season.
So what's happening? How does the connectivity look like? So we've configured the proxy client and we said, okay, if you're going to the internet, here is your proxy endpoint, and it would be like some sort of ID, nfw.proxy .region.amazon AWS.com. So that will represent the proxy itself, and we're telling the proxy client to do that. So whenever the proxy client does the initial connection, so what's going to happen is, first of all, and maybe I'll just do it line by line. So just kind of represent each component and we'll draw what's going on. So the first thing that's going to happen is proxy client and the proxy set up a TCP connection. At this stage, proxy doesn't set up a TCP connection to the internet yet. Right? So far, it's just set up, there's a TCP connection, and then on that TCP connection, proxy client sends a HTTP request, and that's a specific type of HTTP request, HTTP connect. So that's specifically used for proxies. And what this is doing is saying, I know you're a proxy. I want you to help me connect to this specific destination. And it would in there specify, hey, I want to talk to Amazon.com. Right, so then the proxy receives it. And I'm going to mark this in color, maybe in red. So this is, at this stage, the proxy does the first phase of policy evaluation. And there's really 3 phases. Actually, I'm going to jump into the demo and I'll show you the 3 phases. And we'll jump back and forth, but I'll show you the phases here. So let me zoom in a little bit. On the network firewall, we now have all these 3 different components: rule groups, configurations, and proxies. And let's look at the proxy configuration. When you create it, you actually have the actions for 3 different phases: pre-DNS, pre-request, and post-response. So these are applied at different stages of that communication pattern that I was just showing you. So the first one is pre-DNS. So this is where you can apply a policy before the proxy does a DNS resolution for your request. So number 1 here, this is pre-DNS. Proxy goes and looks at the policy and checks if you allowed Amazon.com in the pre-DNS policy. I'll show you examples in a second in the demo. But ultimately, this is where it's going to check if Amazon.com is even allowed in the first place. The proxy is what's doing the DNS resolution. So proxy sends a DNS request, and I don't have a third destination here, so I'm just kind of going to go like DNS.
There's a Route 53.
Yeah, it could go to Route 53, or it'll go anywhere that this VPC where you have your NAT gateway is configured. Right, so
there's a question from Tech First, not Tech Fueled. For Route 53 DNS firewall in place, do we need pre-DNS policy for this?
Yeah. So you probably would want, if you're using a proxy, network firewall proxy, you probably want to use that instead of the DNS firewall policies, because it's no longer the client doing DNS resolution, it's the proxy. If you do have DNS policies that are blocking it inside of the VPC, you can probably relax the pre-DNS policies on the proxy. But I feel like because you have the pre-DNS options to configure on the proxy, it's probably going to be a little bit disjointed if you now have more settings on the Route 53 DNS and not on the proxy policy. Although right now, like in the preview, there isn't any managed policies that the proxy provides you with, right? Whereas if you look at the Route 53 DNS firewall, it comes with a bunch of preset policies that you can just deploy and remove a bunch of malicious IPs or domains without you really doing too much effort. Right now, nothing like that is available for, at least in the preview, for the proxy. So for now, it probably does make sense to use the DNS firewall as like having some level of policy that have some automatic rules already there in place. But in the long run, assuming that the proxy eventually supports like managed DNS lists, I would probably keep that policy on the proxy itself, because then you're keeping everything in one place, right? You're not kind of, oh, I don't know why something's blocked. My proxy looks okay. Oh, I forgot I have a policy on the DNS firewall as well.
Also, be careful if you're doing things like Active Directory on AWS and you're using Active Directory with Network Firewall Proxy. Your resolution, as Tom mentioned before, might be from 2 different places. You might be, because Active Directory typically uses Windows DNS for its resolution. And it's not always, I've seen within customers, tied in with Route 53. And Route 53 is usually used for like the rest of the non-groupware things. So I would also say just make sure that, if you're resolving to 2 different locations and you're using the proxy firewall, you're going to want to put them in both places. And then for Route 53, also remember that's a globally set thing, right? So everyone's going to inherit that. That's going to resolve from Route 53. And if you need to be explicit. So and just keep in mind, like, where your traffic, know your flows, all that stuff. We always say that over and over again. Keep in mind where your traffic's coming from and how you're resolving. And that should also help you answer that question. And then lastly, I always hate repeating everything. So having a block on the firewall as well on DNS, and that's going to be the norm, it's probably best to only do it in one spot. Every time you block, every time you add a hop, every time you add a rule, you're adding latency, and you're also adding configuration.
Yeah,
All right, I'll shut up now, Tom.
yeah, it does make sense if there are managed rules available, because then you can kind of match what you have on DNS firewall. And the nice thing with the proxy is that the DNS resolution, we're not relying on the client.
Right.
So the client at this point, we don't care about its DNS resolution, right? It's not able to connect to anything that the proxy doesn't allow, because the proxy is doing the DNS resolution on the client behalf. So that's a really nice feature here, that it's just really, we don't care what the proxy client configuration is for DNS. They could be bypassing Route 53 and trying to connect to like a public DNS resolver. Doesn't matter, because they won't be able to get the HTTP traffic out, because we'll do DNS resolution on their behalf and then decide is Amazon.com actually allowed or not.
I'm going to ask one other question too on behalf of the audience. Does this work also for internal? So do I need to worry about this if I'm going to resolve an intranet site on my cloud of having something allowed in my proxy if I turn this on, or will it still be able to resolve it naturally?
Yep. So whatever this NAT gateway can resolve, because this proxy lives on the NAT gateway, right? So let me just add here, this is NAT gateway. So whatever DNS view your NAT gateway has, the proxy inherits that view. So if you have a private hosted zone attached to your VPC that resolves to something that's private, you can hit the NAT gateway, and then if you have a route to that private destination, you can not go out through the internet gateway, but route, to your private destination somewhere.
Cool.
Okay, so we got to the HTTP connect, client telling the proxy, hey, I need to get to Amazon.com, help me. We're doing a DNS resolution, applying the first phase of the policy and saying in the pre-DNS policy, what's allowed, what's denied. We're allowing Amazon.com. Only then there's a TCP connection established between the proxy and the internet destination. And once that is established successfully, then the proxy goes back and responds HTTP 200 on the connect, which ultimately means, hey, I established the connection for you. So now you can send the request that you actually want me to handle. And at this point, the client sends a HTTP get, or whatever is the request, HTTP get for Amazon, let's say index.html, and the host header is amazon.com. Right, so this is the second phase now, because now we're seeing the request from the client. And this is the second phase. So we were looking at the configuration here. This is the pre-request inspection phase, where now we can look at additional information in the request. Maybe we want to limit based on some header or some path, whatever that is. So we apply that policy, and if that is allowed, then proxy will forward that request to the actual destination. So that HTTP get comes from the IP address of the NAT gateway and is destined to the Amazon.com. Amazon.com responds, hey, here's the site that you wanted, P200. So that's the response. And that's finally a third phase, the post-response phase, where we can decide based on the header or some information from the response, not the payload, unfortunately, today, but header information. What do we want to do with this request? Do we want to allow deny? And if it is allowed, oops, we finally pass this to the destination.
Yeah, so a good example of 2 and 3 is that if, let's say, you have some servers that should only get to a specific portion of a website, maybe the website's like more globally available, maybe it's like a ticketing site or something like that. And if they have any changes or any customer or anything you want to restrict anyone getting from, like billing or anything from that site, you can then on phase 3 say, hey, if the response has this in it, don't allow it. So you can literally restrict people to different sections of a larger website if you're savvy enough with 2 and 3, which is pretty cool.
The other question that comes up here a lot is now, okay, what about TLS? Right, this traffic typically is encrypted. Like HTTP is next to nothing out there. So all of it is, we just assumed it should be all TLS. So what's going to happen is you can operate without TLS, but it will limit the ability of the proxy to apply other policies, right? So if you don't decrypt TLS, you can allow for the TLS session. I'm just going to use another color here. the TLS session, you either have the option to have a TLS session separately between the client and the proxy, and then another TLS session between the proxy and the real destination. At this point, the proxy is in the middle, it's terminating TLS. It's able to look at all of the information in the request response and apply appropriate rules. You can also just do a pass-through for TLS. So have a TLS directly between the client and the destination. The challenge with that is you won't be able to apply all of the policies, right? So you can't even see the specific path that someone's trying to connect to, because that's going to be in the encrypted part of the request.
Mhm.
So all you're seeing is DNS pretty much, maybe SNI, IP addresses, anything that's visible outside of the encrypted payload. If you do TLS termination, then you can look into headers, path on both request and response.
And then the next question is MTLS supported or not supported at this point in time?
I'm not sure, actually.
I didn't think it was, but I'll look it up now that you're making me question my question my life.
Yeah, I'm not sure. It's if we pass through, if the client tries to identify itself with a TLS certificate, I'm not sure if what's the proxy going to do? Something to test out, I guess.
Yeah, I don't think the proxy is going to pass the cert. Does the TLS termination require public certification on the proxy? That's a good question.
Yeah. So from a certificate point of view, there's going to be a public cert for Amazon.com, right? Or any destination you're trying to get to. There's no way you're getting that certificate, right? So you can't get a public cert for a site you don't own. What you can do is use private CA, which is an AWS service that allows you to generate a private certificate authority certificate, and then install that certificate on all of your clients so that they trust this CA certificate, and then integrate the CA certificate with your proxy. So there's two actions here. You're setting up your private CA in AWS. You either generate the CA certificate or you bring in the root CA certificate from elsewhere, but you still need to use private CA. And then you integrate with the certificate you want to use with the proxy, and then you push that certificate on the client so that it's trusted. And then what happens if you're doing TLS intercept? The proxy auto-generates the certificate for Amazon.com if it's trying to get you to Amazon.com. If you're connecting to, Facebook.com, it will generate Facebook's certificate on the fly. And this only works if the client has the trust with the private CA. Otherwise, you're just going to get a certificate error and you say, hey, why is some weird proxy certificate here signing my Amazon.com
Trying to do a man-in-the-middle attack or something. Yeah. Hitherings is just asking a question we had answered before, but Maz will just reiterate. Again, this only works with the VPC NAT gateway, not with the regional NAT gateway at this time.
Yep. Okay, so we can probably go and do a demo. Let me see how we're doing on time.
We got some time.
Yeah, we're doing good. So let me just go back a step here and show me my VPC. So I have an egress VPC that I created. It's super basic. It's a single AZ, so I didn't want to do too many AZs because otherwise it would get messy. And I like using this. Let me just make some more room. I like using this resource map here. It allows you to see all the subnets you have, and I only have two subnets, public and private. And then it shows you which route tables are used for each one and to what are these route tables pointing. Right, so here we can see that the public subnet, and I'm just going to draw it out as we go and then show you all the building blocks. So we have a VPC. And then we have a private subnet. And then we have a public subnet.
You're going to do the public subnet in red?
I'm going to use colors for other things. So like I'm keeping it. Yeah.
Teasing you.
Okay, so public subnet using public route table, and then the destination it's pointing to is the internet gateway. So that's solid, right? We're here at the public subnet.
Egress only. So this is an IPv6 subnet, I'm assuming?
IPv4.
IPv4.
Yeah, so it's default for this is internet gateway. And then private subnet would typically have a route to the NAT gateway, but you can see there's no connection here to the NAT gateway, and I can show you what's exactly inside of that subnet. It does have a route to VPC endpoint for S3. So when I created this VPC, I tend to create S3 gateway endpoint pretty much by default, which is a common practice because they're free, the gateway endpoint. So that's why you see this route here to S3. So we know that the private subnet has a route to S3, but it doesn't have a route to NAT gateway. So if we have a look at that subnet, you can see here that it only has the local route. This is the CIDR range of the VPC, 10.0.0.0/16. Right, and then the VPC endpoint for S3, and there's no default route. So it's pretty much isolated. So here, default doesn't exist. And then here we have a NAT gateway. Single AZ right now, don't do single AZ at home.
So one thing, just to kind of work in Tech First's question about what if we have a transit gateway in the path. So the subnets in the VPC, you got a transit gateway, you got NAT and an egress type VPC, and you want to do the proxy firewall on the NAT gateway.
Yeah,
why would that not work or work?
it would work. Yeah, but you can really go wild with the world's your oyster with how you can connect to the proxy, right? So when you create a proxy, and I'll draw it out and I'll show you what gets created. So let's go back to network firewall and skip all the traditional firewalling components and look at just the proxy. So all the proxy settings are here. And like we discussed before, it's under the network firewall umbrella, but it ultimately shows up as a completely new feature. And it's configured differently. The policies are different. It's attached to the NAT gateway. So it's you got to use those separate sections to be able to configure it. We'll start from the bottom. Proxy role groups. I don't have a role group right now. We can do it later. There's a proxy configuration. I pre-created one earlier because it takes a few minutes to set up. So I'm just going to show you how to set it up. It's very simple. You say configuration, give it a description, set up the default behavior for all of the phases that we talked about. So here we have denies, but in my one, I'm going to do allow for everything because we just want to test initially if we can get out. Next, attach a rule group if I had a rule group, and that's it. Like super simple to set up, right? So that's proxy configuration. That's just setting up the defaults. And then setting up a proxy. Again, already one pre-created. I'll show you how to create one. Proxy. Here's the proxy configuration that we had. So that's the one that we created earlier. We link it to a NAT gateway. So I have a bunch of here. I want to connect it to the one in the egress. And that's it. So ultimately, this configuration just says, I want this proxy config to be part of this NAT gateway. So I want this NAT gateway to be proxy capable. I can enable TLS inspection. So I do want to enable TLS inspection. I need a private certificate in ACM. So let me just show you. Private certificate authority. I have a couple of certificates. This one deleted one, and then I have this one that I'm going to use. Yeah, it's just a private CA, self-signed. So I just want to use that. So I'm going to use the active one. So that's how I integrate ACM private CA with network firewall proxy. Then I specify the ports I want the proxy to listen on. So the confusing point about this, and a lot of folks think, okay, so HTTP port is the port that you use for HTTPS connection, and HTTP port is the one that you use for HTTP connection. So if I have a HTTP application, I would use this port. That's not the case. So this is just the options of how you want to connect that initial message, that HTTP connect message that we had here. Do you want that to go over HTTPS or do you want that to go over HTTP, regardless of what you're forwarding? So you can still be forwarding HTTP or HTTPS. It doesn't matter. The port is more about how you do that initial connect. So ultimately, we could even ignore the HTTP port and not use HTTP. I think there's a way to maybe disable that in the CLI. I can enable logging. So I can specify where to send my logs for either allow, alert, or deny. And there's a bunch of different destinations, pretty much standard CloudWatch S3 and Firehose. And then I would do create. So that would create this proxy demo for me. And you can see here the name of it, the ARN. It's actually will show you any failure messages that you run into earlier. So this one was where I actually didn't give it the right permissions to be able to grab that private certificate from private CA. So it'll come back with an error, so I had to update the IAM permissions to make sure that it can get it. You can see which NAT gateway is attached to. You can see the certificate from private CA, and then the private DNS name. So this is the DNS name that will locally resolve to the endpoint. So what happened now is we created the proxy configuration and attached it to the NAT gateway. So this is our proxy. As part of that process, an endpoint, a VPC endpoint, a standard private link endpoint is created to point to that proxy in the VPC. It will get an IP address from the VPC range, and we can actually find out what that is if we do a DNS lookup on this proxy name. So let me go to an EC2 instance. And we'll connect to an instance using this client.
And what subnet is that endpoint is created? It's on the same subnet as the NAT gateway, or is it subnet?
Correct. Yeah, same subnet as the NAT gateway. So while we're connecting to the instance, it's going to be, the endpoint is in the same subnet as the NAT gateway. So I'm going to look up what that IP address is in a second. Okay, so we're here, zoom that in a little bit, and then let's do a dig on that host name, and then we can see the 10.0.9.80. So this IP address here is 10.0.9.80. And then the instance I just connected to lives in here in the private subnet. So that's the EC2 instance, the client. And then you can see that from this client, if I try and ping, like somewhere out to the internet, that's not working. If I try and curl and then let's say Amazon.com, you can see that the DNS resolution works on the instance. Like it's able to resolve Amazon.com to a set of IP addresses, but it can't connect anywhere because it doesn't have a route. It lives in a subnet that is completely isolated, right? So it's stuck. So now we need to tell it that it needs to use a proxy to be able to get out. The way to do it with Linux would be to export it as an environment variable. HTTPS _ proxy equals HTTPS, and then the proxy ID, and then the port on which the proxy is listening and on HTTPS. And then we do that. And we can do the same thing for HTTP. Notice here that even though I'm doing export HTTP proxy, this just says for HTTP connections, I want to use a HTTPS connect mechanism still. So I would connect to the proxy of a HTTPS, tell it I want to connect using HTTP to somewhere, but that initial HTTP connect connection would be encrypted.
And this is pretty good for like those legacy apps that only speak on specific ports that grab specific information. You can do a little bit of funkiness here on the proxy if you need to.
Okay, so let's see if we can connect to Amazon.com now. Boom, it's working. We connected. We get a redirect to go to www.amazon.com, but it doesn't matter. We don't need to see too much stuff here, but we see the connection is successful, right? It's 301 instead of 200 because it's saying, hey, redirect, go to a different destination, but it's working. And we can see here that we connected to Amazon.com, but the certificate issuer is Network Firewall Proxy. So we can check from this verbose output that we're actually connecting to a real destination, but the firewall proxy is overriding the certificate and generating a new certificate on the fly. Another destination I like going to is the check IP AmazonAWS.com, which is returning you the IP address that you're connecting from. So this is my instance IP address, or the proxy IP address, or the NAT gateway IP address, to be accurate.
The elastic IP address on the NAT gateway for your proxy.
Yep. And you can see here, this is also, now I go to 200. I connected to check IP. That's the certificate, and it's still generated by network firewall proxy. So proxy on the fly generates the certificates for the destination, and what's happening is I connect to the proxy endpoint from the client, so that's one TLS session, and then the proxy using the NAT gateway connects to the outside world using a separate TLS session. And this is like Amazon.com.
So does this proxy do any caching?
I don't think so. I don't think so right now there's any caching. At least you can't configure it. I don't think it will do any caching without you explicitly configuring something. So yeah.
Back in the old days when we used to set this up on Linux, you would do a root cache as well, just so that you can get faster results. Yeah.
Yep. So there was a question before we check very quickly a policy. There was a question about, can I get to this proxy from other VPCs, right? How would that look like?
So show us how this would work with, like, say, if you put a transit gateway in between our private and our public.
Yeah. So I'm going to do two options. So one option is, okay, I have another VPC, or I have another dozen VPCs. So just a bunch of VPCs down here. And I want to be able to give them access to the proxy. One option is to create an endpoint for the proxy in those VPCs, because this is a private link endpoint. So I can just connect all those VPCs, right, using individual endpoints in each VPC. So then clients in those VPCs connect to the local IP address, and then we transport it over private link to the proxy and break it out from the NAT gateway. So you don't need transit gateway, you don't need Cloud One, you don't need any other mechanism to help you establish this connectivity. You just drop a private link endpoint for the proxy in each VPC.
Can you go back to your console configuration of the NAT gateway?
Yeah. Oops. Of the proxy, you mean, or the NAT gateway?
Yeah, right there. So, like, if you look in the right-hand side under TLS intercept, VPC endpoint services is the way to let you know that this is.
So if I'm in another VPC, so in the preview right now, I think it's locked into one account. Obviously, after the preview, this will work across accounts. So you'll be able to get this endpoint service name, go to endpoints in another account, say create endpoint for AWS service. So this is going to be my proxy endpoint in some VPC. Network firewall. Boom. You can see here, that's the service that we want to connect to. And then I would drop that endpoint in another VPC. So I have a bunch of other VPCs in here that I could drop the endpoint into. It's in the same account right now. So you can't really do different accounts just yet. Like in the future, you'll be able to share the proxy and then set up endpoints cross account, because single account is not really that useful. Other than to like play around with it and see the demo. Okay. Yeah, so you either create these endpoints in individual VPCs, or if you have Transit Gateway or Cloud One, and you already have a bunch of VPCs here, you just need to make sure they have routing reachability to the endpoint that already exists. And one thing to bear in mind here is that when we look at the proxy, there's this name, private DNS name, and I think that doesn't resolve publicly. So let me just get my terminal here. So this is me on my machine. Let me zoom in. And we do dig. See, that doesn't resolve publicly. So if you want to get to the proxy from outside of the VPC that the endpoint is in, you have to go and check the already existing endpoints, find the one that's representing the firewall, and then use the publicly resolvable name, which is the first one here in DNS names. So I copy that and I resolve that locally from my machine. And you can see here that that resolves to the 10980, which we know is the VPC endpoint. So for connecting from outside, you just need to make sure that you use the right DNS name to be able to reach the VPC endpoint. And that's how you would get through. So up to you. I imagine in the long run, most customers will probably be using the local endpoints for VPCs. Yeah. It will probably also depend on like the pricing model and how that's going to look like. And that's, often set as something that, at the very end. So we can't really share anything at this stage about pricing. But once that comes up, I think the pricing model might influence what you want to do. If it makes more sense to have more endpoints and then send data through direct endpoints, or do a combination, because you could, in theory, also have these VPCs have an endpoint and a transit gateway, and then you just decide which one to use, so you could bypass the transit gateway. Now, big call out here is that proxy is for HTTP only, HTTP, HTTPS. So if you have any other protocols, you would still need to use traditional firewalling for that.
Like gRPC and all that.
Yep. I know we have 10 minutes, and I want to touch on the policies very quickly, because we haven't really configured any rule groups. So I'm going to create a rule group. Demo rules. Next. And then we have different phases. So if we would do pre-DNS and maybe we do a deny, or just allow DNS. And we only want to allow a specific host name. So we're going to add a condition, and you'll see that there's a lot of condition keys here, and then divide it into conditions that apply to requests, and then conditions that apply to responses. So you can see here pretty quickly of what rules you can configure if you can decrypt traffic. So response, you can do like rules on header, custom header name, content, status code, but there's a lot more on request. And the one I want is related to not the details about the VPC account or source VPC endpoint. I'm interested in the destination domain. And I want to allow anything. So instead of string equals, I'm going to do string like. I want anything that's star.amazonaws.com, which is the domain we've been testing with. Next, create. So that's one rule. And we're going to create very quickly a second one, pre-request. This is going to deny a specific path. Oops. And we keep it as a deny, add a condition. The source is the URI. So we're going to look into the HTTP URI. And then we want to drop anything that's like star.file/star. So anything that has file in the path, I want to dump it. Realistically, you'd probably be doing a lot more here, more granular stuff, but it's good enough for the demo. Create. So now I have two rules here. One is allowing specific DNS, right? AmazonAWS.com, and the other one is denying a path that's a file. So the next thing I need to do is go into proxy configuration, modify my defaults here, right? Because by default, I'm allowing all DNS. So by default, I want to deny so that my allow rule is going to kick in. So now I'm denying all DNS requests, allowing all requests and responses. I want to attach the rule group I created earlier, my demo rules, and that should be working. So now those rules should be applied.
Let's test it.
Yeah, let's test it. Let's see if it's working. So Amazon.com, we said we only allowing AmazonAWS.com, so that should break. And nicely breaking, 403. Okay, perfect. Does my check IP AmazonAWS.com still working? That's working. I'm getting back my IP address. That's wonderful. Now, the nice thing about this check IP, I can just add dummy paths and it still responds. So it still works nicely. So it's a nice way to actually test different paths. So instead of dummy, I'm going to say files. Or file. Did I say file?
You said file.
I guess I said file. And then some like random.file. That got 403 as well. So that got blocked because the path matched. So if the proxy is blocking anything, it will just return a 403 for you. So both those worked. I don't think we have time to look into the response rules, but it would be similar. You would be looking at the parameters in the response and maybe blocking on a particular content type if you want to.
So with the 6 minutes we have left, I promised Tech Fueled we would answer the question, what are some of the reasons why we'd want to do this? What are some of the applications that we can see?
Yeah, I think the biggest one is customers typically already know if they want to use an explicit proxy or if they want to use a transparent proxy. Right. So I would say, Yeah, I would say that's the biggest driver of the directionality. If you already have an explicit proxy in place, right? Maybe using Squid, maybe using some commercial option, and you have to managing instances, scaling, etc. With a managed offering, you don't have to deal with any of that, right? You're just having AWS. AWS is managing the proxy for you, and then you're just configuring the rules, and you don't have to worry about scale. But usually, what I've seen, customers already have a predefined mechanism. Some
Right.
customers feel like the explicit proxying is the way to go. Some customers prefer transparent proxying. Uh, there's pros and cons, I guess. What's nice with explicit proxying is there's no accidental like, oh, the route was there and traffic was able to get out.
Mm-hmm.
You just don't have a route out. You're completely isolated and you have to use a proxy. So that's your only way out. And the proxy also does DNS on your behalf. So there really isn't a way to bypass the proxy if that's the only way out.
Yeah, I've seen this actually, this paradigm, if you will, the Squid and whatnot, especially in FinServe as well as healthcare, where there's a lot of regulation and government to a degree for defense contracting. There's usually like you have to show me proof as an auditor that I can only get to these particular sites, right? And no matter what you do to your environment, you can only get to these particular sites under these conditions. And this is literally perfect for that. And there is
Yep.
other applications too, where I've seen like for migrations, like in a lift and shift, like we described before, if you have to do a bit of transform between HTTP, HTTPS, and the ports, if you're bringing something legacy on-prem, typically I'd see like a Squid proxy being put in place to do a lot of that mangling for you until they can modernize the app. And as you mentioned, this is definitely a managed situation where you don't have to go through all that configuration and all that crap to
Yeah.
maintain it, patch it, and all that.
Yeah. And it's still like, I think what customers might like as well is those different phases. I find that
Mm-hmm.
kind of really nice that you're able to chop something
Yes.
off at DNS level, pre-request, post-response. I think they're pretty nice and clear. The only thing, fingers crossed, future looking, is that we're going to be coming up with some managed rule sets so that you're not in business of like creating these rule sets from completely from scratch.
Right, right.
Um,
And the other thing too is if you had like an ecosystem, if you will, of a small group of VPCs that you want to also be super isolated, but allow to go out to go patching or whatever, right? They're not connected to with a VPC peer or VPN or transit gateway, but you still want to give them a very small, very controlled amount of internet access to be able to patch themselves, or even phone home to IoT devices or whatever. This is a perfect solution for that as well.
yeah, I think the other thing I want to touch on is for the Lattice, you actually are able to attach the proxy, integrate a proxy with Lattice as a resource.
Right.
So I've seen some customers interested in that model. I can just pop that in the chat, because we have a blog that touches on that, and it has specific integrations at the bottom with Lattice, and we're doing cross-region because you can just put it behind a private link if you want to. So there's some interesting patterns that you can build and attach it to your existing solutions and expand them. Because I've seen customers go, we like Lattice, we're using it for our own applications, but I also want Lattice to be my gateway out to the internet.
Right.
Right. And currently that wasn't supported, but you can attach a proxy as a resource to Lattice, and all of a sudden Lattice becomes your exit to the internet through the proxy.
You could also do a resource gateway to FQDNs, but you'd have to be very explicit. Where this is the opposite direction, where you can just
Yeah.
be very deniable, which is a really cool way of doing it.
Yeah. This is pretty much a star access to the internet, right?
Yeah.
Through Lattice, or if I think the benefit of integrating this with Lattice is going to be the fact that you don't have to create a separate endpoint because Lattice already gives you an endpoint. So you attach it to Lattice instead of popping another endpoint in each VPC.
Hmm.
But ultimately, you can do both, right? So you can have individual endpoints for the proxy if you want to.
Yeah, that's pretty crazy. Lattice is the future. We had to bring in Lattice. You didn't mention AI, but we got Lattice in there. So we have 1 minute left. I know our producer is furiously waving his hands because we can't go over. Tom, thank you very much. Final thoughts. What's one thing that you want everyone watching or listening to take away from this?
It's in preview, so have fun with it, right? Have test it out, check out the configuration, see what you like, what you don't like, and yeah, let us know. You can ping me and Jamie directly on LinkedIn if you
Mhm.
wanna, or you can contact your local account teams that you're working with. We love hearing feedback, so yeah, just play around with it.
And then also keep your eyes peeled. Next year, early next year, we're going to be covering all of the um, reinvent sessions that were Chalk Talks. That's where you get to ask us questions. We'll bring those guests back on, and you can take advantage of it right here on the Routing Loop.
Okay. Cool.
Until then, see you guys next year. Happy holidays.
Happy New Year.